Hello. The question of interest is of 2005, question 12. The question reads, two lines, line 1 and L2, intersect at a point P. L1 passes through the points -4, 0, and 0, 6. Given that L2 has the equation y is equals to 2x minus 2, find by calculation the coordinates of P. Remarks. Let's get the solution. Well, the question is two lines L1 and L2 intersect at a point P. So there are two lines. Let me just draw this. These are two lines. Yes. Okay, they intersect at a point P. So let me call this L1 and call this L2. Those are two lines. And we are told that L1 passes through points. So L1 passes through points -4 and 0. And another point it passes through is 0, 6. Given that L2 has the equation y is equal to 2x minus 2, find by calculation the coordinates of P. Yes. Find by calculations the coordinates of P. So they intersect at P. So P is here. P is here. So in other words, we want the coordinates at that point of intersection. So one, I have this line that's already specified. Then I need to define this line. Once I define this line, then I equate it to this line for me to get and solve simultaneously to get the value of x and y. So it will be, the general line is y is equal to mx plus c, where m is the gradient or the slope, and it's given by change in y over change in x, dy dx, which will be, if we check change in y, it will be 6 minus 0 divided by 0 minus 4, which is 0 plus 4. That gives me 6 over 4, and that is 3 over 2 as the gradient of line 1. Then now I can then define the equation. I can define equation of line 1 by picking an arbitrary point anywhere along the line that I don't know its coordinates. So let the arbitrary point be if n, let me call it n, it's n, and it's all the coordinates x1, y1. That's a point anywhere along the line. So I'll be using that line and any point, either this or that, and the gradient to define the slope. So without calling it, I just call it x1 to make a difference between this and this. But even if I don't put the subscript, it should be known that if this is point P and this is point N, then definitely the x and y coordinates are different because they're different points. So I would then say y minus, using this point, one of them, I could use this or that, minus 6 over x minus 0 should give me 3 over 2. That implies that if I cross multiply, it should imply that 2 into y minus 6 is equal to 3x. Making x the first, I open the bracket. That will be 2y minus 12 is equal to 3x. In other words, 2y is equal to 3x plus 12. So that is the equation of line 1. So we have equation of line 1 and line 2. So I want to solve them simultaneously to get the value of x and y, which will be the coordinates of the point P. So our two equations then become, the first one is y is equal to 2x minus 2. That's one. Then 2 will be this, 2y is equal to 3x plus 12, like that. So we've got two equations that we want to solve simultaneously to get the value of x and y. So let me first rearrange so that I have unknowns one side and knowns the other side. So I'll be having first y minus 2x is equal to minus 2. That will be 1. Y minus 2x equals to minus 2. Then 2y minus 3x is equal to 2y minus 3x is equal to 12. So that's Roman 2. So in order to solve simultaneously, I can eliminate y. And if I want to eliminate y, then I'll have to multiply the upper one by 2. So that should give me in effect 2y minus 4x is equal to minus 4. That's line 1. Then the lower one just remains 2y minus 3x is equals to 12. I eliminate by subtracting this minus that is 0. Then minus 4 minus 3, that's minus 4 plus 3, which is minus 1. So I have minus x is equal to minus 4 minus 12, that will be minus 16, implying that x is equal to 16. Now, if x is 16, then we can then substitute it in either this or this to find the value of y. So in that case, I'll use that equation. We say, but y is equal to 2x minus 2. Therefore, y will be 2 times 16 minus 2, which is 30. Therefore, the answer that we want is x is 16 and y is 30. Now, those are the coordinates of point P. So, for candidates who are about to sit, this work is majorly Form 2, but it's worth revising over and over again before you sit your 2024 examination. Success, and meet you in my next video.